right, so we made it into the haunted house and we ended up bouncing up 5 ghosts, and let's see what they have to say. So I'm hoping you all remember the storyline from last week. All right, so they agreed to help us to find the murderer, who apparently is a wizard, but we have to find an item for each of them. All right, so we didn't get a chance to do this one last week. This one is now a reflection in the line y is equal to x. You don't have to draw the graph like I mentioned, right? And, oops, 1 second. But I would like you all to take down the note in yellow. That's the instructions on how to reflect something in the line y is equal to x. And last week, I believe that I showed you what the line y equal to x would look like. It's a special line in maths that I hope you commit to memory, right? Right, so give you a few seconds for that and we'll try the question together. So let's say we're in the exam and they ask us to reflect this in the line y is equal to x. Now, there are 2 ways we can do this question. The first way, right, the harder way would be to use this formula. I want you to go back in the notes and look for this formula, the matrix that represents a reflection in the line y is equal to x. Does everyone agree that this here is that matrix? 0, 1, 1, 0. Great. So the hard way to do this question, right, would be to memorize that matrix. And just like last week, we would go to all the points individually. Let's start with point A. And we would take point A and multiply it by the matrix. Now, point A is -2, 1. We always put the x coordinate on top and the y coordinate underneath. And what we would do, well, let me put A on top so you remember that this is A. I want everyone to take this blue matrix and multiply it by the pink matrix. Let's do it the hard way first, right? And let's see what happens when we do that. Right? Even if you could predict the answer without working it out, do me a favor, still work it out, right? Being able to multiply matrices, it's really, really, really important in maths, not only for this topic, but for other topics. Refresh your memory. So what we have to do now is take this matrix, the smaller matrix, the pink matrix, and remember last week I told you, you look at the underneath number and let this number swing up to the top, right? So on top, we have -2 and 1. Remember, the 2 numbers would walk across. So the -2 will end up here and the 1 will end up here. The 2 yellow numbers, which are on top, they also get photocopied underneath. And just like last week, we are going to multiply each pair. -2 multiplied by 0 is 0. 1 multiplied by 1 is 1. 1 multiplied by -2 is -2. And 0 by 1 is 0. To get the new coordinates, there's a top answer and an underneath answer. To get the top answer, we add the 2 top values. 0 plus 1 is 1. To get the underneath value, minus, we add the 2 underneath values. Minus 2 plus 0 is minus 2. So that means when we reflect it in the line y is equal to x, where does it end up? Look at the values of that point. The top is the x, the underneath is y. 1 minus 2. 1 is somewhere around here, and minus 2 here. Let me get a different color there. So a prime is 1 minus 2. Look at it again. 1 on the x-axis, minus 2 on the y-axis. You all notice that we did the same exact thing the yellow note was saying. Anytime you are reflected in the line y is equal to x, all you are doing is switching the places of the x and y value. Look at it. A was minus 2, 1. Therefore, a prime was 1 minus 2. We just switched positions. Which way would you prefer to continue this question now? Would you prefer to continue using the matrices method? Or if you were short on time in the exam, would you use the shortcut method? Which one would you prefer to use? Right. I would prefer also that you use the shortcut method, especially if the examiner never told you which way to use. So I want you all to finish off this question now. I want you to find B prime and C prime using the yellow note. And you can just probably do a quick sketch of the answer if you want to, right? And let's see what you come up with. Without any major calculations, B, if it gets reflected in this line, right now it's minus 2, 4. So all we have to do is switch the x and y value. So we'll get 4 minus 2. Right? So this is B prime here. 4 minus 2, right? I mean, let's write this in a better position for you all here. Right. So A prime would have been 1 minus 2. All right, you're kind of about it, but that's a minus 2. C, if we switch the values, would be what? 4 minus 8. It will be somewhere down here. C prime. 4 minus 8. And of course, if we connect this up, we get a triangle. That's the reflection of the first triangle in this line. Remember, we're just pretending that the slanted line is a mirror, and the triangle is standing in front of the mirror and seeing its own reflection. How much of you all, I know most people may not have actually drawn the graph, but you were pretty much imagining what I had as the solution. Like you were on the right track at least. Let's move to the next slide, right? So, when I explained this one already, you could have used this formula if you wanted to, but you're going to end up with the same answer by just switching the x and y value. So let's progress with the story here. Do you all remember the name of the first ghost? I forgot to tell you how to take down the name of the first ghost. Anybody remembers the name of the first ghost? It was Suzette, right? So remember, if we want Suzette's help, we need to find a precious item for her that was hidden in the house by the wizard. Her most precious item when she was alive was a ring. And there's a picture of the ring there. Anybody just wants to take a guess of why that ring was so special to Suzette? I'm always interested in hearing about what the students think for these movie scenarios. A lot of people are going to say it was her wedding ring, right? I'm going to give you a hint. It has nothing to do with marriage, this question. So you find the ring and you're going to touch the ring. But every time you touch the precious item, you're going to get a flashback. And the flashback is going to explain why the item is so important to the ghost. So you touch it. All right. All right, so we'll go to the flashback after this question, and we're going to see why it was so important to her. Do you all think you can do this question for me? No, sorry, we don't have to do it. Sorry, we already did this question. My plan was to do it the shortcut method and then make you do it the long method. All right, so we don't have to do this question because we already did it. My mistake, guys. Which means that we get to go to the story. Just take it in here for a little bit. Oops. So this is part of the story. Apparently, Suzette had a daughter, and her daughter gave her the ring. I want everyone to take close attention to the date. Anybody wants to tell me why that date is so special in history? What's so special about that date? Right, a lot of you all know your history. That's the day the Titanic sunk. So that means Suzette's daughter was on the Titanic. But that's not the end of the story. There's a lot more to the story in a little while. Right, next question. This question is the opposite of what we just did. The question we just did was a reflection in the line y is equal to x. And the line y equal to x slopes up this way. But this question is a reflection. You have to be real careful in the exam. Huh? This is a reflection in the line y is equal to minus x. To do this question, look at this yellow note. It resembles the yellow note we just took down, but it's slightly different. Here's what you have to do using the shortcut method. To find the reflection of this shape, you take each coordinate and you're going to switch them. I'm just making up our own example here. Let's say I had the point P, and the point P was minus 2, 5. And you wanted to reflect it in this line. According to the instructions in yellow, you have to switch the x and y, but also make them the opposite. So that means the 5 will go here and the 2 will go here. We switch positions, but we have to make sure they become the opposite. What's the opposite of positive 5? Minus 5. And what's the opposite of minus 2? Positive 2. Do you all think you can do this question for me? You don't have to draw the graph, but do you all think you all can get A prime, B prime, and C prime for me? It shouldn't be too hard, right? You switch positions and make each individual one the opposite. Send the answers on the chat, please. All right, so let's get the answers for A prime. Well, I guess we have the diagram in front of us. So A right now is minus 6 minus 2. That means if we switch it, the 2 will go here and the 6 will go here. We switch it around. Right. And look at it. I did not forget to make the signs the opposite. The minus 2 became positive 2, and the minus 6 became what? Positive 6. Now, for B prime, right? For B prime, we switch it. So the 2 goes here and the 2 goes here. And you notice I made all the signs the opposite. And for C prime, right? The 4 will go here and the 2 will go here. We switch positions. And once again, I did not forget to make all the signs the opposite. So that's the coordinates of where the new triangle, the reflected triangle, would end up. So let me draw. In the exam, you'll need to draw it out, right? But today you don't have to. So the first point is 2, 6. That's somewhere up here. So that's A prime. And you have in the exam, you'll have to put the name of the point plus the coordinates next to it. B prime, 2, 2. C prime, 4, 2. And of course, if I, connect that up, I'm bound to get what? A triangle. That's the reflection of ABC in the line y is equal to minus x. All right. Now, I know a lot of you all did not send any answer. All right. So let's see what's going on with Suzette's daughter. So apparently we reached the point where the Titanic has sunk. All right. So you all can see the ring on her finger there, a little blurry, but that's the ring. Anybody want to take a guess of what the bump on her leg is? Like what is hitting her leg? Is it seaweed? Is it a shark? Is it a whale? Someone says it's ice. Why would the boat be bumping her on the leg? Why would the big Titanic? Well, oh Lord. Someone says it's Jack, and someone says it's a mermaid. Okay, you all have great imaginations. So eventually we will find out what that bump on her leg is after this question. All right, so I want you all to do this question now, right? This one here is a slightly different question. It's a reflection about the origin, right? Now, in case you all don't know what the origin is the center of the graph. This is one of those strange questions, so we're just going to work it out. Now, there are two ways we can do a reflection through the origin. We can use the matrix formula, which we're not going to use today, right? Instead, we're going to use the shortcut method. Now let's pay attention to the instructions. To do a reflection about the origin, or sometimes they use the word through the origin, both of them are the same thing. The values of x and y remain in the same position, but the signs become the opposite. So let me do my made up example. Let's say I had the point 2 minus 3. And you wanted to do a reflection through the origin. According to the instructions, right, the values of x and y remain in the same position. So the 2 and the 3 remain in the same position, but the signs become the opposite. So the opposite of positive 2 will be what? Minus 2, and the opposite of minus 3 will be positive 3. Simple enough, right? And if we were to take each point and multiply it by this matrix, you will get the same exact answer. But I'm not going to stress you out with the matrix right now, because later on, you're going to be given so much opportunities to use the matrix. See, I just want to focus on the, what is called this, the common sense method. I want you all to send the answers for A dash, B dash, and C dash. And answers are popping up already. All right, so let's see who is right and who is wrong. So according to the instructions for a reflection about or through the origin, the values of x and y stay in the same position. So let's look at A. A has a 2 and a 1. They remain in the same position, but the signs have to become the opposite. The opposite of minus 2 is positive 2. You can choose to put the positive, but as we all know, if we leave it out, it's automatically positive. And the positive 1 is minus 1. For B, it has a 2 and a 4 in it. The signs need to remain, the values stay in the same position, but the signs become the opposite. Minus 2 becomes positive 2. Minus positive 4 becomes minus 4. Now for C, it have a 4 and well, another 4. Signs become the opposite now. -4 becomes +4. +4 becomes -4. Those are the values. And of course, in the exam, you will be asked to plot the values on the graph. So A is what? 2 minus 1. This is A dash, right? 2 minus 1. B is 2. And we're going down to -4. That's B dash. 2 minus 4. And C is 4 minus 4. And when we draw that, this is the triangle we get. Right? For those who did not submit answers, well, of course, everyone can let me know. Did you get everything correct? All the calculations, and were you pretty much, well, I'm gonna go on the assumption everyone here can plot points on a graph, provided that you got the coordinates correct in the first place. All right? Right, so in detail when we start the past papers. You see how A changed to A dash? This is how you write it in maths. You don't actually write a sentence, A has been changed into A dash or A prime. There's a mathematical way to actually write that. And this is how you would write it in the exam. A, which was the point, -2, 1, you put an arrow. This means it has been changed into, and then you put the answer, 2 minus 1. Now, the official name for this arrow, well, when you use it like that, you just call that mapping, right? So A has been mapped to this point. In other words, A has been changed into this point after we did the reflection in the through the origin. All right. So if you want to, for the rest of the class, if you want to practice the format, you can. But when we reach the past papers, I'm going to refresh your memory on it in any case. All right. So let's move on. Let's see what that bump on the leg is about. I'm actually excited to see myself. Well, for those who guessed it was a shark, and for those who guessed it was a mermaid, both of you all were correct. Right, so I guess Suzette's daughter met a gruesome death. All right, not the best death. So that's why the ring is so precious to Suzette, right? Because her daughter, that was the last thing she was given by her daughter before she met her end. Yeah, and I know that type of shark doesn't eat people. It's a whale shark, but I was low on free images. All right, somebody's asking what the point of the mermaid is. I don't know. I made that last minute. All right, so here's another type of question. Now, this question, I'm going to ask you all to draw it. You don't need graph paper, but draw up an X and a Y axis. Make sure the X axis goes up to 12. The Y axis goes up to 9. Draw it fairly neat. This is one of those few transformations that I need to make sure you actually do it in class before you leave here today. So let me know when you're finished with an okay-ish neat drawing. Draw the triangle as well and label it. I'll give you, I think 5 minutes should be enough. That should be fair enough. So let's read through the instructions here. They want us to enlarge ABC by a scale factor of 3. So that means, well, whenever you're trying to enlarge something, obviously we're trying to make it 3 times larger. So simple English, right? So that means at the end of the question, the triangle is supposed to look 3 times larger. So that, at least that will give us an idea if we're on the right track. Now you have to read the rest of the question. In these types of questions, enlargement questions, they have to give you the center of enlargement. The center of enlargement is where you are going to pretend to stand up in the question, and you're going to pretend you have a laser gun and you're going to shoot lasers. So in today's question, the center of enlargement is the origin. So that means we are standing over here, put a little black dot here, right? We all know where the origin is. That's where the X and the Y axis intersect. So I want everyone to use their imagination now. Pretend that you are standing up at the origin and you are going to shoot lasers at each point. So you're going to shoot a laser at point C, you're going to shoot a laser at point B, and then shoot a laser at point E. So let me see, I just need some space here. Right, let's get started. Look at what's going to happen. From the origin, I shoot a laser at point B. I just chose B first. You could choose A first, you could choose C first. Since we are trying to make the triangle 3 times larger, the first laser that you shoot at whichever point you choose first, you see that length, that is considered to be 1. We need to go up to 3. We are going to have to enlarge this line by the same length 2 more times. I'll explain why it's 2 more times. So the first laser is 1. We continue the line. 2. And then 1 more. 3. So you see how much we got in all? How much lasers did we, the first laser you shoot is 1. And then you have to extend it by 2 more times to make it to what? 3. So what you will need to do in the exam, the first laser, you're going to have to measure it with your ruler. And then whatever length you get, extend it by that length and the length 1 more time. I need for everyone to do that and tell me if you end up close to the point 12, 6. You're going to see this twice again, so don't worry if you didn't catch it the first time. Let me know if it ended up somewhere where I have it, by 12 and 6. Right? I just labeling it, right? The first laser is 1, the second laser, the second extension is 2, and the third extension is 3. All right. So let's continue. Let's see, let's shoot another laser. Where will I have to choose another point now? So this time is the blue line. You all see it here? I took a shot at point C. So using my ruler, I'm going to measure the length of the blue line. And then whatever I get, I extend it 1, 2. Tell me if when we extend it by 2 more times, bringing the total to 3, did it end up by 3 and 3? Did it end up somewhere around here? Right. By the way, this is point B prime. This is B prime, and he's how much? 12, 6. Right? If it did not end up by exactly 3, remember, you have to cater for the fact that not everybody here is using graph paper. And it kind of all depends on how neat you drew the graph in the first place. Right? Right. If it doesn't end up by 3, 3, just follow along with what I am doing. Right? But the majority of the people are getting 3, 3. That's somewhere around here. And this is the point C dash, which is 3, 3. What's the last remaining point we have to shoot? We took a shot at B. We took a shot at C. What's the next one we have to take a shot at? A. So from point A, from the origin, we shoot a laser. You see that green line connected to point A. Use your ruler and measure the length. And whatever you get the length as, you're going to extend the line twice. In other words, I'm just saying if. if the length of this line was 4 centimeters on your graph, you're going to extend it by another 4 and another 4, making it 1, 2, 3. So extend it once again, that's that green line, and extend it one more time. And it should take you close to this point here, which is 3, 9, somewhere around there. Right? So the majority, I see the majority of people are getting it right. I'm going to make sure and do other examples as we go along. Triangle. Connect up the 3 points now. After you complete it, let me know on the chat if you got something resembling the orange triangle. And now we have some stuff to discuss about this. So the shortcut to doing this question, let's look at point B. No, remember, B prime is what? 12, 6. And the original point B was how much? 4, 2. So because we are trying to enlarge it by a factor of 3, a lot of people said, hey, why not just take each point and multiply it by 3? 4 by 3 is what? 12. 2 by 3 is what? 6. And of course, that is a shortcut to doing the question, but you have to be real careful about that shortcut. It only works in certain instances. So let me explain what this certain instance is. Whenever they say to enlarge it by a certain factor, like if it was 4 or 5 or 2, fine. We can just multiply all the coordinates by that particular number. But you have to ensure that we are standing by the origin. So this shortcut method only works if the center of enlargement is the origin. If the question said to stand over here, for instance, like this is not the origin, this is the 0.71. If they had asked the same exact question just now, but the only difference was to stand at 7.1, the shortcut of multiplying just by 3 would not have worked. And that's really, really important. And don't worry, I'm going to try to trick you today. You're going to get another enlargement question today. But the center of enlargement is not going to be the origin. And I'm going to see if you remembered what I said here today. Right? Great. And I just letting you know, right? Just to answer a question. If they had said to enlarge instead of 3, they said to enlarge by a factor of 2, this same question, you would have drawn the line once up to the point, and you would have only extended it one more time. 1, 2. You just always have to remember the first laser that you shoot counts as 1. So that means if it was an enlargement of 4, I'm just saying if it would have been 1, 2, 3, and 4. Everyone pretty much okay with the fact that the first laser you shoot counts as 1. I want to make sure we leave understanding that the first laser it counts as 1. I used to forget that in school. So that's why I'm stressing on it for you. Right. Okay, clear. Let's move on. Right. So Elizabeth's most precious item when she was alive was a message in a bottle. Right. So we're gonna touch the bottle. It's going to reveal, give us a vision of why that is her most precious item. Anybody want to take a guess of why something So strange is the most precious item to Elizabeth, a message in a bottle. Oh, one person has a good guess. They said it's a treasure map. Maybe she was a treasure hunter. Somebody said she was a pirate and was a treasure map. Okay, a family secret. All right, guys. So here's another way of doing this question, right? We're going to do an enlargement again. But this time, we're not going to use the drawing method. The examiner, like I can just pretend to be the examiner, can ask you to do the enlargement using the enlargement matrix. Now, one thing to note, right? You see this formula here, the enlargement matrix, K00, K. If you look back at your notes from last week, it only works if the center of enlargement is the origin. So it only works if you pretend that you're standing up at the origin shooting the lasers. It doesn't work for any other point. Anybody want to take a guess? Since that the enlargement factor is 2, we are trying to make the triangle twice as large, right? Do you want to take a guess of what to replace the letter K with? What's the most obvious guess? 2, right? Great. No rocket science there. So if you have to use the matrix method, since it's an enlargement of 2, you replace both K's with 2. 2, 0, 0, 2. And guess what you need to do? You are going to visit each point one by one, like point A. How much is point A? A is 1 minus 2. Remember, you have to write it vertical. The X goes on top, the Y goes underneath. Take this yellow matrix and multiply it by the, well, point A and tell me what you get. All right. This is the one where the minus 2 swings up to the top. And you do this for all the points, right? You take 2, 0, 0, 2, and then you multiply it by point B, which is 3 minus 2, and then you repeat for point C. I'm not going to go through the matrix C, how to do the matrix C multiplication, right? I think we did it enough. You just need to get your answers and send it. Some of you might notice a pattern, but please, in the exam, if you are multiplying it and you see a pattern, you still have to put all the work in for the examiner, right? That's just how CX is. So if you were to use the matrix C method, right? And the minus 2 with a swing up to the top, and you do a little calculations, you would get 2 minus 4. For this one, if the minus 2, all right, was to swing up to the top, you would get 6 minus 4 here. Could use a better color here. Oy. Right, and for C dash, you would get 6 minus 6. How much of you all had all of these correct here? 2 minus 4, 6 minus 4, 6 minus 6. So let me plot that, right? And then I know some of you are really, really interested in seeing back the drawing method. So I'll use this example as an excuse to do it back, right? So the first point is how much? A dash is 2 minus 4. 2, and then we're going down to where? 2 minus 4. So this is A dash. 2 minus 4. B dash, which is really B prime, I keep saying dash, is 6 minus 4. 6, and we're going down to minus 4. Right? And the other one, but that's pretty easy, right? That's 6 minus 6. 6 going down to minus 6. Right? So let's connect that up. Tell me something. Does this triangle look twice as large? There's an easy way to verify it. You just take one side. Look at this side. In the original shape, this side was how much blocks? One, two big blocks. And look over here. It's 1, 2, 3, 4. And this side was one big block. And look at it now. 1, 2. So you can just visually see that, hey, this triangle is twice as large. Now, let's just say you wanted to do it by the drawing method. Let's say if, right? How you would do it, since the center of enlargement is the origin, you would be at the origin and shoot a laser at point A. What you would need to do is measure the length of this line and extend it one more time. For example, if this line was 3 centimeters long, you would take your ruler and extend it by 3 centimeters one more time. And you would end up here still. You will still end up at 2 minus 4. And then the same thing for point B. You draw a line from the origin to point B, you measure this length, and since the scale factor is 2, you extend it one more time. So if this length was 6 centimeters, the total length of this line would be 12. And you would do the same thing for point C. Draw a line to point C. If the total length was 8 centimeters, you extend it by 8 more centimeters, giving you a total of 16 centimeters. And if you did that, you would end up in the same exact positions over here. All right, so take a 20 seconds, take down what you need to. Here what, I'm gonna give everybody, take a half a minute and take down what you need to take down. I think the 20 seconds is a little too small. All right, so let's continue with, what's her name? Elizabeth. Let's see why this message in a bottle is so important to her. All right, so for those of you all who guessed that she had something to do with being a pirate, you're on the right track, right? But you notice they said something will be coming back, right? Anybody want to take a guess of why they are so frightened? They said something will come back soon. Someone says it's the Kraken, sharks. All right, we shall see in a little while. All right, so this one here, everyone is going to have to draw this diagram neat. So while you're still drawing, for those who are still drawing, quick question. They ask us to enlarge it by a factor of 3, just like a couple questions ago. Remember, the enlargement matrix is K, 0, 0, K. And since it's an enlargement of 3, I just saying, if we did not want to use the drawing method, let me just say we wanted to use the matrices method. Can I use this matrix and still get it correct? 3003. Let me see if you all fall for this trick. A few people said yes by mistake. The answer is no. Remember, this matrix only works if the center of enlargement is the origin, if you are pretending to stand up by the origin. But if you read the question carefully, right? They said the center of enlargement is not the origin, but the point what? -1, 3. But I already put it in on the diagram for you, okay? And the examiner will not put it in for you in the exam. I just happen to put it in for you. So in a case like this, there is no matrix method on the CXC syllabus that you can use. So because of the center of enlargement is not the origin, you have no choice but to use the drawing method, since this is not available to you. So pretend you are standing at point P and shoot your lasers and see if you can do this question without my help for the first 2 minutes. Get started. Even if you get it wrong, you get it wrong. Just try your best. I'm asking you not to give up. Just try something. Right? K just represents the value, like the enlargement factor. So if they tell you to enlargement by a factor of 3, you replace the K's with 3. If they said it was an enlargement factor of 4, you replace the K's with 4. Let's see how my answer looks. If you look at it, right, let's just take 1 point here. If I went to A first, so I shoot the laser from point P to point A, I would measure the length of that line and then extend it 2 more times. 1, 2, right? So the first laser is 1, and the other 2 extensions count as 2 and 3. And if you do that with all the points, you're going to end up here. Oops, bad. Here, here, and here. So over here, C prime looks like how much here? That looks like 11 minus 3. B prime ends up at where? 11 minus 6. Let me see here. This one here looking like 11 minus 6. I'm making sure. And A prime looks like 5 minus 6. I see some people had 12 here by mistake, but it's really supposed to be 11. For those who got 12 here by mistake, by the C and B, you understand your mistake? You may not have used graph paper, no, so I can understand why it may have gone off by 1, right? It really supposed to be 11. That is not a problem. If you have 12, just change it back to 11. And of course, if you join up these points, you will notice that the triangle actually looks 3 times larger, and I can prove it. From A to B is how much big blocks? 1, 2. Here's 1, 2, 3, 4, 5, 6, right? 6 is 3 times larger than 2. And this side here is 1, 2, 3. And over here in the initial diagram, it's only 1. Right? So recheck it. If you made any mistakes, just let me know. Hey, you saw your mistake and you're good to go. And of course, if you got it 100% correct, let me know also. All right, so let's see what's going on with Elizabeth. She's overboard the ship. I can only imagine something bad is going to happen. Right. So I guess it was a good thing that Elizabeth was overboard, because if she was on the ship, she would have been killed, right? All right, so here's another one I need for you all to draw properly for me, right? Let me see if I can get the coordinates. In this question, it's a reverse question. You all can clearly see if I label the triangles, triangle 1 and triangle 2. Triangle 2 is the enlarged version of triangle 1, right? The question is, where are you shooting the laser from? That is what is missing, and that is what the examiner is trying to find out from you. So to get where the laser is coming from, all you have to do is connect the similar points. We know A change into A prime. So you connect those 2 points. And what you want to do is kind of backtrack, meaning that when you connect A dash to A, extend the line. Just extend it. You can just go all the way, right? And you're going to do the same thing for all the points. Connect B, B dash to B, and go all the way back with a ruler. And do the same thing for C dash. Connect C dash to C and continue the straight line. And eventually, all the lines will meet at a common point. Now, let me show you how that will look in the exam. See, I connected C dash to C, and I went all the way back. Then I'm going to do it for B. I connect B dash to B, and I go all the way back. And then I do the same thing for point, the A's. And you notice all 3 lines come together at a common point. All of them intersect at one point. You just need to read off the coordinates, which is 4, 5. That's the center of enlargement. That is where the laser was being shot from, right? Now, obviously, to get the exact answer, I have 4, 5. You would have to do it super, super neat on graph paper, right? If you do it kind of freehand and whatnot, your answer is going to be off a little bit, right? Anybody wants to tell me what looks like the scale factor? How much times the triangle got larger? Did it get larger by 2 times, by 3 times, by 4 times? Right, it looking like 2 times, right? And what you could do, look at it. If you take, there are 2 ways you could do this. If you take a ruler and measure it from 4, 5, the center of enlargement, and you get a distance, you will notice that the next line is just one extension of that line. Hence, the enlargement is 1, 2, not 3, it is 2. Right? So for those who are saying 3, at least let me know you're understanding mistake. Or why not measure the length of one side of the triangle? Measure the length of this side of the triangle, and then measure the length of this side of the triangle. You will notice that this side is twice the length of the other side. So that's an easier way of trying to figure out the enlargement factor. Right. All right, so let's see what happens with Elizabeth. Right, so apparently remember she was overboard the ship. She washed the shore, deserted island. And you know how people use, you've heard people asking for help. They will put a message in a bottle and throw it in the ocean, hoping that someone would find the message and rescue them. But there's a sad part to the story. So she doesn't have a happy ending. So poor Elizabeth. All right. So that's Elizabeth's story. Obviously, next week, we're going to continue with the rest of the ghost, right? So I guess she died of old age. All right. So let's get to the homework now, right? All right. Sorry, 1 second, guys. Okay. So what I'm going to do on the screen, don't send anything on the chat for a little while, right? Let me just send something for those who were not here last week, right? I'm sending back the YouTube link and of course the school website. Part of the homework, right? When you go to the school website, you all have to visit the summer recorded classes. last week, when you scroll down, this is the Monday mark, right? So I already uploaded last week class. I'm going to upload this week class right in this same position here. So make sure it will be up there tomorrow. So everyone is supposed to go through it, no exceptions. Everyone is supposed to go through this week's class, the one we just did, get good graph paper, draw back all the examples, make super good notes, and come back next week for to continue from where we left off. Also, I'm hoping by now everyone went to the maths classroom, right? So I'm hoping that everyone went to the maths classroom and they went to lesson 1 as agreed last week, and you did videos 1 to 7, right? So that was mandatory homework, and it had some worksheets and whatnot. But it have some additional homework today. I just wanted to clear it up with you guys. I'm writing it out on the screen here, so no one has an excuse. Next week, there are a lot of harder matrices to do, to multiply out. And I need for everyone to, when you go to the summer recorded classes, you see how it have the Monday math, it have the homework you need to do extra assignments. It have 2 matrices videos I need you to watch. And they're very weird. It's very cinematic. It has some animations in it. But see if we can, I know some of you will get annoyed by the little animations, but I put it there to help you out, right? So make sure and watch these 2 videos. Make sure you have it clean for next week. I'm not going to pause next week to explain back how to multiply these more complex matrices, okay? So I'm going to put the homework here on the screen. Everyone screenshot it. So no one has an excuse of not knowing what the homework is. When you are finished screenshotting it, send a message on this chat that it's finished and you're gone, or something like that, like understood, and you're free to go. All right, take care, guys. Right, I'll be staying back a few seconds just to clear up any